I will be introducing proportions and going through how to solve some various proportions and one or two rational equations. This worksheet can be found in Blackboard under the Unit 4 worksheets with this title. And there will also be some other problems. After I finish these 7 problems, I'm going to go over 3, number 5, number 6, and number 12, okay, from another set of worksheets that I'll be posting in Blackboard under Unit 4 worksheets as well. Okay, so this will give you an idea of some strategies to use for solving proportions. I'm going to encourage you to use the same approach and just get used to it. There are faster ways on some occasions. But I'll try to be consistent in how I present this. First off, proportions are just a special type of rational equation. If you have a fraction in your equation, you have a rational equation. Okay, and anytime you compare two numbers, really, if you said 15 out of 20 students like texting, you just identified a ratio. 15 out of 20 can be written as the fraction 15 over 20. That's one way to write a ratio. And you realize that 15/20 could be reduced to 3/4. So if I said 15 out of 20 students like texting, I could also say that 3 out of 4 students like texting, and essentially I mean the same thing. Usually we will give you, let me zoom in a little bit. Usually instead of giving you, obviously there wouldn't be anything to work on here, but we'll give you a fraction equals a fraction with one position missing. Notice we have an x up top, on the bottom, upper right, lower right. Okay, this is usually how we give you the proportions. This is a little more complicated, but this is still a proportion. Over here, this is not a proportion, this is a rational equation. But we're going to solve it the same way as we solve the ones up here, okay, just to reinforce that you can use the same approach each time. Let me see now. So for our first one, and I'm going to use an approach that we did use in the first unit this semester, we cleared the equation of fractions. Normally when we're doing this, we want you to multiply each side by the least common denominator. To emphasize that this method keeps working pretty much no matter what we throw at you, I'm going to use the same approach where instead of the least common denominator, which in this case would be 20, I'm going to multiply by the product of 20 times 4. And I'm actually going to write it that way. So a common denominator, it's not the least, but it's a common denominator, is 20 times 4. So I do that on this side of the equal sign, I do that on this side, 20 times 4. And then we just go in and cancel what we can. Twenty goes into 20 once, 4 times x is 4x. Bring down your equal sign. Then you have 4 goes into 4 once, 20 times 3. And notice I'm just going to write 20 times 3. I don't have to multiply them together. And I'm just trying to show what in some cases is going to be an easier way to keep up with all the numbers that you're given. Okay, now you want x by itself. So divide by 4, divide by 4. Over here it cleans up very quickly. 4 goes into 4 once. 4 goes into 4 once. 4 goes into 20 5 times. And 5 times 3 is 15. We use the same approach for each of these 4 problems. So on our next one, in the denominators, we have an x and a 4. So I'm going to multiply each side of the equation by 4x and 4x. X goes into x once, 4 times 15. And again, I could multiply that together, but I'll keep them separate for now. And then 4 goes into 4 once, you just have 3 times x. Now you want x by itself, so divide by 3, divide by 3. 3 goes into 3 once, so you have x equals, and 3 goes into 3 once, goes into 15, 5 times. 4 times 5 is 20. Alright, that's the second one. For the third one, again, the least common denominator would be 20, but I'm going to multiply by a common denominator, which is 20 times 4. So I do the same on each side and just cancel what I can. 20 goes into 20 once, 4 times 15. And again, I'm not going to multiply it, I'm just going to show right here that they need to be multiplied. Bring down the equal sign, and then 4 goes into 4 once, and that's 20x. Get rid of your 20, so divide by 20, divide by 20. And 20 goes into 20 once. Here, let's do a little reducing. 4 goes into 4 once, 4 goes into 20, 5 times. But you can go a little further. 5 goes into 5 once, 5 goes into 15, 3 times. So out of this big old mess, the only thing left is a 3. And then finally on our last one, our common denominator, in this case it is the least common denominator, is 20 times x. So here's 20x, 20x, and the whole reason we're doing this is to get rid of our denominators. So 20 goes into 20 once, and you have 15x. Bring down your equals. X goes into x, and you have 20 times 3. Forgot to show that I was multiplying. That was x times 15 and 20 times 3. And let's see, we want x by itself, so divide by 15, divide by 15. X equals, and here, 3 goes into 3 once, 3 goes into 15, 5 times. And we can go a little further. 5 goes into 5 once, 5 goes into 20, 4 times. So out of this whole mess, the only thing left standing is that 4. Okay, so for each of these 4, I solved it the same way. And on this one and this one, there was a faster way to solve it. I could have just, on this side, I could have just multiplied each side by 20. I would have x by itself. Over here, I could have just multiplied each side by 4, and I would have had x by itself. But I'm just trying to underscore that this same approach works every time. Let's take a look at these others that are a little more complicated, but we will be using the same approach. See if I can zoom in on us a little bit here. Alright, so our least common denominator, again, all I need is a common, but in this case it will be the least common, is going to be 5 times this quantity. So I'll just write 5 times 3x plus 2. On this side of the equal sign, and then on the other side of the equal sign I write the same thing, 5 times 3x plus 2. Now we cancel. 3x plus 2 goes into 3x plus 2 once, and you have 5 times 7. I think I'll just go ahead and I'll write it as 5 times 7. Again, it doesn't matter. I could have written a 35 there. And let's see. There's our equal sign. What can we cancel? 5 goes into 5 once, so you have 8 times all of this, 3x plus 2. All right? So here's 8 times the quantity 3x plus 2. And we're going to, if 8 would divide evenly into something over here, I would just divide each side by 8. But that's not the case. So I need to send in my 8 and work at getting x all by itself. So this gives us 24x plus 16. I think I will go ahead and multiply them now. So there's our 35. And let's get rid of that 16. That leaves us with 19. That's a 0. You don't have to write it. And just one step away now. Divide by 24. Divide by 24. I'll back out one more. And 24 goes to 24 once. You're left with x equals 19 24ths. So that is our answer on that one. Again, we're using the same approach as previously. The same approach is on these 4 problems up here. All right. And even for this problem, which is not a proportion because you're adding or subtracting something else. So this is a rational equation, but we'll solve it the same way we've solved the previous 5 problems. Let me zoom in a little bit. Okay, so the least common denominator is going to be our 7x minus 3. So I just put that over each side, each term on each side. So here's 7x minus 3, 7x minus 3, and over top of this negative 4 there's 7x minus 3. Technically these are in parentheses. They're grouped together. It's not going to matter really until we get over here to this 4. Well, things clean up quickly here. 7x minus 3 goes into 7x minus 3, so it's just 1 times 2. Bring down our equal sign. 7x minus 3 goes into 7x minus 3 1 time, so it's 1 times 9. And we'll bring down the negative. Notice nothing cancels here, so we actually have to bring down the negative 4. And nothing cancels this out, so the 4 is going to have to multiply both terms. So we'll do that first off. Let's send in our negative 4. So that gives us negative 28x plus 12. And what else do we have here? Here's our 9. All right, let's combine these two terms. 9 and 12, 21. So it's 21. Bring down our minus 28x. Bring down the 2. Now get rid of your 21. It looks like another 19 is showing up here. So that's a negative 19. Whoops. I think I'll zoom out a little. And equals negative 28x. Now we have to divide by our negative 28. So those cancel. You have x equals negative divided by a negative is a positive. So we're going to end up with, usually I keep going down the page, but I have another problem right here, so I don't want to write over that. But x equals 19 over 28, so I'll put that right here. Alright, so that's what we ended up with for that problem. Alright. And now we'll solve our last one on this page. And again, we will be using the same approach that we have used. We'll simply multiply by a common denominator. In this case, it is the least common denominator. Notice on the left here, maybe I can zoom in one. We have our x squared minus 49, the difference of squares, which can be factored into x plus 7, x minus 7. So that's actually our common denominator. Alright, so that's what I'll be multiplying each side by. So this is x plus 7, x minus 7. Then over this term, I have to put x plus 7, x minus 7. And then over this term, I have to put x plus 7, x minus 7. Okay. Notice I just put the exact same thing over each term. And now we cancel whatever we can. Remembering that x squared minus 49 is all that, this goes into that one time. So it's 1 times 3 turns into just a 3. Bring down our equal sign. Then x plus 7 goes into x plus 7, and you're left with x minus 7 times 5. Alright? So there's 5 times x minus 7. Now I'll bring down this negative sign. It's right there. And x minus 7 cancels x minus 7, and I have 2 times this quantity. Plus 7. Okay, now to clean this up, we need to get into these parentheses. So send in your 5. So we'll have 3 equals 5x minus 35 minus 2x minus 14. And let's see what we can combine. The negative 35, negative 14 combine to give us negative 45, negative 49. And the 5x, negative 2x combine to give us 3x. Just bring everything else down. Let's say add 49 to each side. And this leaves us with 51. Let's make that a 52. And here we just have 3x. Divide by 3. Divide by 3. That cleans up quickly, and you have x equals 52 thirds. Okay, that one got a little long, but the essential point is that you can solve these clearing of fractions the same way, even though each of these problems looked quite a bit different. Okay, now there are some worksheets that I also have posted under Unit 4 worksheets. I'll zoom in on this a little bit. And I don't think you can really read that, but it's solving proportional equations and other rational equations. And in these worksheets, number 5, 6, and 12 could cause some confusion. So let's take a look at them. Number 5 is going to be quite similar to what we were just doing. We will clear this of fractions. We will multiply each side by a minus 5. So in order to do that, we will multiply each term by a minus 5. And even this 6 is going to have to get multiplied by a minus 5. Okay? And I'll put them in parentheses. It's not actually critical, but maybe it'll be more clear what's happening. In this denominator, the fraction bar itself acts as a grouping symbol. So this fraction bar implies parentheses for these terms. All right. So a minus 5 goes into a minus 5 once. 1 times 5 is 5. We bring down our equal sign. Then a minus 5 goes into a minus 5 once. So you have 1 times a. I'll bring down that plus. And then we have, there's nothing to cancel down here. So I'm just stuck with the a minus 5. So it'll be 6 times the quantity a minus 5. All right, now we want to get into this set of parentheses, so send in your 6. This will give you 6a minus 30. And just bring everything else down. This plus sign, the a, and the 5. Certainly you can combine like terms, so that's 7a minus 30 equals a 5. Get rid of your 30. So add 30 to each side. now we have 7a equals 35. And one more step. Divide each side by 7. Divide by 7. Divide by 7. I think I'll zoom out. So 7 goes into 7 once, and you're left with a equals 35 divided by 7 is 5. Okay, we've ended up with an answer of a is equal to 5, and normally that's not going to cause a problem, but if you recall, our original equation had a variable in the denominator, and sometimes that can cause a problem. We've solved it correctly. Every step was correct, and we legitimately figured that a is equal to 5. But now if we check that answer, if I take a 5 and plug it in wherever the a is, if I put a 5 right here, I'm going to have 5 minus 5, which would give me a denominator of 0. So the entire equation is undefined. You cannot work with that. And again, here it would happen twice, but if it happens once, that basically does us in. So a cannot equal 5. It's not equal to 5. There is no solution. This won't occur a lot, but you should be aware it can come up. For this one, I would, yeah, we could clear it of fractions multiplying each term by a y, but let's just get rid of that 4 for starters. So it's held by addition or subtraction. We use the opposite sign to get rid of it. So -4 and -4. So now we're left with 5 over y is equal to 2. Well, maybe I should have left a little more room there, because, well, I'll show it this way. For every problem I've done so far in this video, whatever I was multiplying by, I always wrote it above the terms, but maybe on this side there isn't room. I'm just going to put it next to it. I want this y out from the denominator. So I could either say I'm just getting it out from under the denominator, or I could say I'm clearing the equation of fractions. This y is held there by division, so I multiply by y and multiply by y. This is really like y over 1. So y cancels y, and I've got 5 equals 2y. And one step to get y by itself. Divide by 2. Divide by 2. 2 goes into 2 once, and you have y equals 5/2. And now we finally will solve number 12, and I'm going to use the same approach I've been using, multiply by the least, well, by a common denominator. In this case it will be the least common denominator. So that means I have to multiply each term, this, and that, by x minus 1. So I'll write that above each term, x minus 1. I'll go ahead and put it in parentheses. As long as you understand that they're grouped together, it's not critical to put the parentheses. And now we go back and cancel whatever we can. For the very first one, x, there is no denominator, so I can't cancel. So I just end up with x times x minus 1. That just comes down. And this has to multiply. Alright, then we bring down our minus sign right here. Bring that down. Then x minus 1 cancels x minus 1, so you just have 1 times your 19, or negative 19. Just gives you negative 19. Bring down your equal sign. With this 4, there's nothing to cancel. Okay, so it's going to be 4 times the quantity x minus 1. This negative here, I'll bring it down. And one more canceling. X minus 1 goes into x minus 1. So it's 1 times 3x. Okay, now we'll need to get rid of these parentheses and see if we can clean things up a little. So we'll send in the x to each term. Then minus 19. Send in the 4. Bring down your minus 3x. Let's combine like terms. So on this side we would have 4x minus 3x, x minus 4. Over here I could, well actually I can't factor. That's in that form it's not factorable, but we're not quite finished. So let's just bring that down. X squared minus x minus 19. Alright, when you have a term squared, you can't just get x by itself the traditional way. Like if all I had was x minus 19, x minus, well, this wouldn't be solvable. But let's say it was 5x minus 19 equals x minus 4. There would be a way to solve it. Just get rid of the 19 or get rid of the x, something like that. But when you have an x squared, the only trick we've learned so far is the zero factor property. So I'm going to zoom out a little bit and pursue that strategy. I want this equals 0. I want to be able to factor it and then equals 0. So we're going to add 4, and let's just do this in one step. We'll add the x, okay? Whoops, we got to subtract x, don't we? Let's make that clear. There. So to get rid of this x, we're going to subtract x from each side. Alright, so that'll be a minus x here. And remember with the 4, we're adding 4. And let's see what we've got now. X squared minus 2x, and that's negative 15 equals 0. Look at your factors of 15. 1 and 15, 3 and 5. A negative 5, positive 3 would give us that negative 2. So that's our factored form. X plus 3, x minus 5. If you have something times something equals 0, you can use your zero factor property. So x plus 3 equals 0, or x minus 5 equals 0. And get rid of the 3. So you found out that x equals negative 3. And over here you would add the 5. So we have x equals 5. Zoom out a little. Alright, well this one got kind of long. But anyway, well, I can go in one. We figured out that x equals negative 3 and positive 5. And if we plug a negative 3 or a positive 5 in our original equation, we don't have any problems with our denominators turning into zeros. So these answers do stand. Negative 3 and 5.